Hey all, this is Jason, your full stack engineer, and today I wanted to go over the round robin for US government. So at the core of how it works, there is basically a script called bin run, and all that does is use the run function from the Zendesk class in the round robin module, which doesn't explain a whole lot. So let's go over it a bit. So kind of starting off, we'll use the Zendesk class, but essentially run is going to output the current workload and it's going to output the workload variable. We'll go over that as we get down to the function that defines that. It's going to run the determine updates function. If there are no updates, it's going to just output a string and then it's going to exit with a 0 status code because that's not a fail pipeline. But if not, if there are tickets to update, it's going to run the update tickets function, and then it's going to tell us what the workloads are after having done that. So the update tickets function really is just making a Zendesk API call using a put request to tickets update many, and it's literally just sending off a mass update for all these tickets that it finds. Updates is a blank array at start, but we add to it as we go. We do that by using the determine updates function. And that's going to use the queue, which is a variable that we define further down. We'll cover that in a bit. It's going to start by determining who has the lowest workload. We'll cover how it does that in a bit, but it's then going to push an update that is just the ticket object with the ticket itself, queue in this case, and the assignee, and it's going to add 1 to the workload of said assignee. It's doing that because at start a ticket has a weight of 1. So ticket object is just a Ruby object that we use for updating a ticket. In this case, it's setting the assignee and it's setting the weight to 1, and it's saying that it has done the round robining. So lowest workload is determined by getting the minimum value of the workload array, or workload hash rather. In the situation where it cannot perform this, that would mean that the workload hash is empty. There is not a way to sort it. There are no people available. It's going to hit a no method error. We have a rescue here that is then going to post in Slack. This will ping James to let him know that the round robin is reporting there are no agents available. So to determine the queue, it's actually real simple. We just make a Zendesk API call to a specific view. This is the ID of that view, but essentially it is our not round robin view, and grab the tickets object from this request. That's what the queue is determined. So in the case where it's 0, it's going to get an empty array. In the case where there's 10 tickets to update, it's going to get an array of 10 tickets. So workloads are. We use the determine workloads function to define it the first time. That's what this double pipe equal means, is define if not defined. So the first time we call this workloads function, the at workloads variable is empty. It's not defined. So it's going to run this determine workloads function. On subsequent calls, it's already been defined. It's going to use the value it already has. So determine workloads is really just going to call the available agents function, which is in the client file. We'll cover that in a second. And what it's going to do is set everyone to 0 to start out, and then it's going to define a query string and make a Zendesk API call using that query string. Essentially, it's saying, give me all the tickets assigned to this person that are less than solved. It's then going to iterate over the results of that and basically add the ticket weight to this person's workload. So ticket weight is done by finding the this field ID, which is ticket weight. I know, original naming. In the case where the field is blank, like it's not defined on the ticket, and it's an emergency ticket, it's going to get a value of 5. In the case where that field is blank and the value itself is blank, so it has the field but the value is blank, it's going to get a 1 value. Otherwise, it's going to take the value of the field, which is weight underscore some number, and get just the number of that by doing a split on the underscore and getting the last value of that split, which would be the number, and then we just kind of force it to an integer with 2i. Theoretically, that's not necessary, but it helps, especially since, up here we just do a plus equals. We want to ensure we're using the right thing. So essentially that's how it works, but obviously there are some definitions here we're not quite familiar with, like there was the available agents. So let's go over that, and that's defined in the client file. Kind of just going over some of this. Retry options, this is just an object we use for Faraday connections. Zendesk client, this is where we set up the actual client for that we set up a Faraday connection to Zendesk. Zendesk request is just using this Faraday client, this Faraday connection to make a public send. And then we're using OJ to render the response. OJ is just a nice gem that renders basically JSON into a Ruby object that's really easy to parse and looks nice. Theoretically, I could do JSON.parse response.body, blah, 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 but OJ kind of makes that a lot easier. It makes it a lot easier, nicer. We set up 2 different Slack clients because we have 2 different URLs. In the case where there are no agents, we want to post in the US government channel and the managers channel. So we have 2 different Slack clients for that. The GitLab clients there, I've set it up. That's basically because part of this once a month is going to need to update the references and the tags used on the source project. But here's where we get into the real nitty gritty. So agents is determined by using this data agents file. That's basically where we define the agents. What we're defining is the ID, their email, and are they overnight. That's in case we need to scale later to where we have to run this for non-overnight and overnight people. Right now, not really necessary, but I like to think ahead. On PTO, we're getting from the Google API class that we define. We'll go over that in a second to get a PTO list, basically for today. And then available agents is basically saying, okay, so of all the agents we have for US government, reject any that are on PTO and are working overnight. That is currently what we're doing for availability. So let me go over the Google API. It's nothing too complex here. We set up a start time just to make it a nice little object we can use. Same for end time. We have the scope string that we use because we're accessing PTO calendar. This is just the authorization used. This is where we define the service that we're attaching to, which is the V3 calendar service. Calendar ID is where we're setting a calendar ID. And events is where we're actually querying for the list of events. And that's going to do that by using the authorization to fetch the access token. And then it's going to tell the service that the authorization is based off that access token. And then it's going to say, okay, now list me the events where the time min and time max is between these start times. Give me a max of 250. There could be a point in time where with hiring and all that, we have to go beyond that, but 250 well covers us at this point. So the actual PTO list, we run the determine PTO function, which we come down here and you see how it starts with an empty hash, and then it's going to iterate over these events. And namely the items in the event. And an event from the Google API is not as simple as I would like. So there's the event and it has a bunch of metadata, and then there's the items in the event, which is what we actually care about, because that's where we're going to get who's on actual PTO. So unless the agent of this PTO event is within our contacts, it is somebody who is a US government agent, it's just going to skip it. It's going to skip the iteration. No point in querying it, no point in parsing it. It's not relevant here. Now, if the end date is before the beginning of the current day, it's also going to skip the iteration because, I mean, if you're not off today, then it really doesn't matter. In theory, this actually doesn't do anything because we have that min max, but the way Google does their querying stuff, you could have you put PTO in for 20 days and it's going to give you that entire event of the all 20 days, not just the current day when I query for the current day. It's going to basically then add to this hash that is the list variable to add various this is the day, here's the array of people who are on PTO by their email, and it's going to return that. So that's kind of how we're collating everything together to make it work. Quickly go over this, but essentially the Slack class is just using the Slack clients to post a message, and the message is, whatever text we send to it. In this case, it's pinging James, letting him know that no one's available. Cool. So that's basically how all the scripting works. That is then used in a CI/CD pipeline schedule that runs every 10 minutes between, currently we're going to do it for not overnight. So we're going to do it for the business hours of US government. It'll run every 10 minutes within that span, which I think is 5 a.m. to 5 p.m. or 5 to 17. We're only doing it Monday through Friday. So your Tron ends up being, */10, 5-17, and then ** 1 to 5. But yeah, that's a very brief overview of how the round robin works. Hope you found this informational, and see y'all in the queues.